All right. So we're going to get zeros in the bottom left-hand corner and zeros in the top right-hand corner. And the nice thing is when you do that, you've got the identity matrix. And if you had something like this and you were solving a system of equations, it would tell you that x was equal to 1, y was equal to 2, and z was equal to 3. And you know all the solutions right away without having to do that substitute back as you go along. Now, depending on the equation, it might feel nicer and quicker to substitute back. And other times it might just be nice to get it into this form so you know what all the solutions are right away. And of course, this is going to be called, the other one was called row echelon form. This is reduced row echelon form. And there's also a button for that in your calculator as well. So here's our first example. Like before, we're going to get this one here to be a 0 first. Now, in order to do that, I'm going to have to change my row 2. My row 2 is now going to equal row 2 minus row 1. Row 1's not changing. I still have 1, -2, and 10. But if I take row 2 and minus row 1, I'm going to get 0 here. 4 minus a -2 is going to give me 6. 16 minus 10 is 6. Now, this is where we would have stopped in the other system and solved for it. In this system now, we're going to get this 6 to be a 1. How could I get that 6 to be a 1? Well, I'm going to take my row 2 and make it row 2 and divide it by 6. I'll write it down here. Row 1 didn't change. But now, when I take my row 2 and divide it by 6, I get a 1 in the bottom right-hand corner. Now we're very close to having into reduced row echelon form. All we have left to do is get rid of that -2. We're going to do that by taking row 1 and adding 2 of row 2 to it. So row 2 is not changing. Row 1, well, 2 times 0 plus row 1, that's not going to change. This will now be 0, and 2 plus 10 is 12. So we know that x is equal to 12 and y is equal to 1. Sort of as, well, we'll put a 2 by 2 here with everything reduced. There'd be a number there and a number there. Just sort of labeling things. We do this first. We get this to be a number second, number 1 second. And finally, we get this 0 third. Depending on the question, sometimes you might then need to divide again to get a 1 in the top left-hand corner, but not always. So one of the things we do is if we have a 1, we might switch rows to make sure that we start with a 1 in the top left-hand corner because it makes things easier, which we saw in the other class as well. So here's one for you to try on your own. 4, 6, 2, negative 1, 3. Now, if I want to get a 0 here, where the 2 is, I'm going to have to take row 2 and subtract 2 row 1s. Now, that's not changing row 1, so I can keep that all the same. And 2 minus 2 would be 0. Negative 1 minus 8 will be negative 9. And 3 minus 12 would be negative 9. Now I can take that row 2 and divide it by 9. Or negative 9, actually. And then I get a 1 in the bottom right-hand corner. Now to get a 0 where the 4 is, okay, I'm not changing row 2. And this will still be a 1. 4 minus 4 will be 0. And 6 minus 4 will be 2. So x is equal to 2. Oh, this time it's a. A is equal to 2. B is equal to 1. What's the pattern for getting this to start with? These are your coefficients. There's 1a, 4b's equals 6. Oh, you have to get this to be a 0 first, then this to be a 1 second, and then this to be a 0 third, and if necessary, this to get a 1 fourth. But if you have this as a 1 already, then it usually works out that you didn't have to do that. How did this one go? Everybody able to rearrange it? To begin with, so that you could put it into a matrix? So you can have any multiple of a row and add any other row to it. So if I want to get a 0 down here, okay, that would be easiest if this was, the second row was multiplied by negative 2 and then added to the first row. So I could do that. I could take my second row and multiply it by negative 2 and then add it to row 1. Now my row 1 isn't changing here, so I still have 4, negative 3, and 23. Now if I multiply this by negative 2 and add negative 3, I'm going to get negative 13. Negative 10 plus 23, 13. Then I can get that to be divided by negative 13. And now I already know that y is going to equal negative 1. Now I can get row 1 to equal row 1 minus plus 3 row 2's. And that will give me 20 there. Row 1 divided by 4. So x is equal to 5. And y is equal to negative 1.